Now, in writing algebraic expressions, which is quite possibly the most difficult part of solving algebraic word problems, your job can be made easier or more difficult by how good you are at writing a let statement, specifically at picking the right thing, the right missing quantity to be your variable. Okay, so what is a let statement? Let statement is just a thing you start your word problem off with that tells the person reading it, which is me, your math teacher, what your variable means in this problem. And when you come up with a let statements don't need to be very ornate. You know, they're not like a mission statement. They're not very elaborate. They often just look something like this, like let R represent the number of, I don't know, something that starts with R, Roombas purchased by Dave or something. Okay, so it's not, it starts with let, the word let, which is really just saying, okay, let's pretend that this letter represents this thing. Those are the parts. So the word let, then a letter, then it represents or an equal sign, and then the thing that it actually represents. So we'll see some examples of this in a second, but remember, you're just telling the person who's reading this what the variable means in this problem. It should always be a number that we don't know. When people first learning let statements, sometimes they actually write a let statement for a number we do know. No, it's got to be an unknown quantity. And when you get to more complicated ones, and there's multiple things you might write let statements for, you got to pick the quantity that other numbers in the problem that we don't know connect to. All right, so let's start with an example. We've got a flower shop where roses cost $1.50 each more than sunflowers. Charles buys 8 roses, 5 sunflowers to make a bouquet for his mom. What algebraic expression represents the total cost of the bouquet? So we're gonna write a let statement here, and the let statement we already know what a lot of it's gonna look like. Let something equal something. So we need a letter here and then a concept. Now, very often I'll get students saying, well, can't we just use X? Say let X represent the blah, 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 blah. You absolutely can, but you'll see, especially in a problem like this where there's more than one thing we don't know, like we don't know how much a sunflower costs, we don't know how much a rose costs, that it's smarter to pick a letter that reminds you what it represents. It makes the problem a lot easier. So if we're going to choose to make our let statement about roses, because we don't know how much a rose costs, then I'm going to write let R equal whatever. If I'm going to choose to make it about sunflowers, then I can make it let S represent blah, blah, blah. In this case, I could either make it rose or I could make it sunflower. The price of a sunflower, the price of a rose. Because again, those two things are things I don't know. I wouldn't do a let statement that says let R represent the number of roses Charles bought, because if I look at my problem, I'll see that I already know he buys 8 roses. I'm not going to write a let statement about a number I already know. I know how many roses he's bought. Not a good let statement. Nor should I have a let statement that's about the number of sunflowers he bought, because I know that he bought 5 sunflowers. Instead, it's got to be about something I don't know, which again is how much one rose costs, how much one sunflower costs. And in this case, I'm going to choose to make my let statement about sunflowers, because we'll see why in a second. So let's do that. My let statement just looks like this. Let S equal price of one sunflower. Notice that I'm being specific here. I didn't just say let S equal sunflower, because that could be confusing. I could think that means number of. By being explicit in writing my let statement, I'm making clear to myself that this is what's unknown, the price of the sunflower, not the number of them. Okay, now we're going to go back to our technique of writing algebraic expressions, the CSI technique, where you say, okay, let me replace this variable with a number so I can write an expression, right? Let's pretend sunflowers cost $10 each. That's not necessarily realistic, but doesn't matter. If a sunflower is $10 each, how much does a rose cost? Well, $1.50 more, I guess that would be $11.50. With actual numbers, I can do this pretty easily. Now, how did I get to $11.50? Well, I did $10 plus $1.50. That's what happened. And now that I've tricked my brain into telling me what I would do, I can recognize that this whole time 10 was an imposter. 10 was just a made up number I threw in there. I'm going to get rid of 10 and replace it with a variable that I randomly made 10 up to replace, and that was S, right? S, that $10 was just the price of one sunflower. So here I have my algebraic expression for the price of a rose, $1.50 more than a sunflower. So we see when we write let statements, we always follow it up in the next stage of solving word problems by writing expressions. S plus 150 is price of one rose. Now you might be looking at this and saying, well, can't I just say, well, let's make S the price of one sunflower and R the price of one rose? Well, when you get to later years, you can start using more than one variable. But we'll see that unless the problem gives you two variables, the ones that I'll give you, it is a rule that you're going to have to stick to just one variable. It's a discipline and a skill you have to learn so that in later years, even when you can use two, maybe even three variables, you have to know how to write one expression in terms of another variable. Okay, so let's figure out the actual problem here. So if he buys 8 roses and 5 sunflowers, what's the total cost of the bouquet? Well, remember we made up $10 as the cost of one sunflower. And then for the price of the rose, I can go with $11.50 for that. Or I could even actually make up a whole new number, but that might make it more complicated to understand what we're doing. So let's just go with this, $10 and $11.50. Algebraic expression for the total cost of the bouquet. So 8 roses, that's 8 times $11.50. And then 5 sunflowers, that's 5 times 10. That's going to give me the total cost. I could even do this, say, this is $92, this is 50, that's $142.50, but this number isn't really important, right? It's more important that that's how I'd calculate it. 8 times $11.50 plus 5 times 10. Now remember, that 10 was just a made up number standing in for the price of a sunflower, which is S dollars. Oh, my S looks like a 5 here. That's a bit confusing. Sorry about that. And the $11.50 was just the price of a rose, which we have here in algebra form is S plus 150. So I have 8 times S plus $1.50 plus 5 times S is the total cost of the bouquet. I could simplify this to get 8S plus 12 plus 5S, and this becomes 13S plus 12. Since we're talking about money, I'm going to put my units, which are dollars. All right, let's look at another example here. Luca buys 3 used games, 5 new games at EB Games. If one new game costs $6 more than the used games, what algebraic expression represents total amount paid by Luca? Okay, step 1, we need a let statement. Our let statement is not going to be how many new games Luca buys. It's not going to be how many used games Luca buys, because I know those numbers. He buys 5 new games. He buys 3 used games. So that's not what my let statement is going to be about. My let statement is going to be about something I don't know. What I don't know is how much a used game costs. I also don't know how much a new game costs, so I could write a let statement that would either be about used games, or I could decide instead to write one about new games. I think it's going to be easier to be adding $6 to some price than taking it away. So I'm going to choose to make my let statement about used games. It could be about new games, and that would be correct, but this just feels a little bit easier. Okay, so if a used game, I need a variable here. I could say let X be the cost of a used game, but then I might confuse the X for new games. So instead, I'm going to use the letter U to remind myself that this is the cost of, and again, I'm being specific here, cost of one used game. I didn't just say let U represent used games because I might confuse myself, think that's the number of used games. It's not. Okay, if U is the cost of a used game, let me write an expression for the cost of a new game using the CSI technique. I'm going to make up a number for you. I'm going to pretend that it's $10 for one used game. And if it's $10 for one used game, a new game costs $6 more, that's 16. That was pretty quick, right? I'm pretty impressive the way I figured out 16. What did I do? Well, to get to 10 from 16, I just added 6. My brain knew to do that because it saw $6 more. Now, with algebra, that might be difficult to write, but with just plain numbers, it was fine. So this here is the cost of one new game. But again, the 10 isn't really a 10. That's just a number I made up to replace u. So over here, when I'm going to write my expression for the cost of one new game, it's going to be what I just figured out, that u plus 6 is the cost of one new game. And if this is 10, if this is 16, again, just made up numbers, then let me write my expression for the total amount paid by Luca. If he's buying 5 new games, that's 5 times 16. And he's buying 3 used games, that's 3 times 10. This actual number here that I'll get is really not important. What's more important is what I did here. 5 times 16, where 16 was just meant to be the price of a new game. I'm going to cross out the number and throw in the algebraic expression. This 10 here wasn't important either. That was just a made-up number to represent the cost of a used game. So I'm going to get rid of the 10 and replace it back with the variable, now that I've tricked my brain into telling me how to do it. And then I'm going to simplify this a little bit. I ran out of space down here, but when I distribute, I get 5u plus 30 plus 3u, which comes out to 8u plus 30, and my units here are dollars.